Hello, this is Chemistry, the Central Science. We are in Chapter 4 on stoichiometry, solution stoichiometry, and this is the end of the chapter questions numbers 15 and 17. Specify what ions are present in solution upon dissolving each of the following substances in water. Okay, remember that if you have an ionic particle, anything that's ionically bonded, it's going to break apart in water. Water will rip it apart, will rip out its positive sides from its negative sides. Okay. The other thing, if you have a covalent bond, but you have an acid will do the same. So B is nitric acid, HNO3. This will rip apart. Okay. So anything that's going to be an ion will rip apart, and anything that's going to be an acid will rip apart. So let's look at each of them individually. Zinc is in the transition metal, so I'm not sure what its oxidation is. I have to figure it out. I do know here that chlorine is in group 7, so if it becomes an ion, it becomes a -1 because it's 1 away from group 8, and I've got 2 negative 1s. That means that in A, I've got zinc 2+. It will break apart into 2+ because it has to balance with 2 negative 1s. And then, well, let me see what they're asking. Do they want me to actually do a, let me see what they're asking. If they're wanting the whole thing, it would be zinc chloride will break apart into zinc ion, okay? And then what's left over? 2 chloride ions. Remember, the chloride is a -1, and I had 2 of them to balance with that +2. And so I'm going to have a zinc ion and 2 chloride ions. All right. What about B? Well, B is nitric acid. It's going to break apart, and it's a strong acid, and a strong acid breaks apart completely. So you're going to end up with, well, let's write it out. HNO3 will break apart into H+. Okay, because it's H+. H is in the first column. It becomes +1. And nitrate, NO3, is -1. Right? How about C? This should be a subscript, NH4. NH4, remember, is the only one that's positive. It's the only one that's positive, and it's +1. So if I have NH4 sulfate, okay, and NH4 is +1, and I've got 2 of them, that means sulfate must be -2 because it has to balance. So when I break it apart, I'm going to have 2 NH4 ions, +1, and I'm going to have 1 SO4 ion, -2. Okay, because it breaks apart 2 to 1. It breaks into 3 things here. Okay. D, I've got calcium, which is in group 2, and hydroxide is -1. I've got 2 of them bounding with it. So this, if this is in group 2, then it becomes 2+. And I have 2 hydroxides. Each is -1. All right, can you see what we're doing? And then all of these would be aqueous. All right, so later that would be aqueous, meaning it dissolves in water. Each of these ions are aqueous also. Right? So when you have something that is a strong electrolyte, it totally breaks apart. It breaks apart completely, like this HNO3. That's a strong electrolyte. That's a strong acid. Or an ionic salt, like zinc chloride, or ammonium sulfate, or calcium hydroxide. These are strong electrolytes. Strong electrolytes, the reason they call them electrolytes is they break apart into charges, and now electricity can flow through that water, well, almost like a wire. Right? So if they are strong electrolytes, they completely break apart. Right? You don't have leftovers. In the number 2, formic acid, this is the acid derived from ants. Okay, it smells like ants. Formic acid, HCOOH, is a weak electrolyte. Okay, that means when you put it in water, a little bit becomes positive, a little bit becomes negative, and it's an acid, so you're going to get HCOOH will break apart into a little bit of H and a little bit of COOH negative. But at the end of the day, mostly what you're going to have is reactant. Okay, so you put it in the water. All right, so this is aqueous. You put it in the water, and a little bit will dissolve, a little bit of the positive, a little bit of the negative, and mostly what you're going to have is leftover solid, okay, because it's not going to break apart completely. So weak electrolyte means it doesn't completely break apart. So write the chemical equation for the ionization. Is that what I write? Okay. Yeah, that's all it is. It just means that at the end, I'm mostly going to have reactant. It doesn't completely break apart, so I'm not going to have only product. In the test tube, I'm going to have a little bit of this, a little bit of this, and a lot of this left over. Okay, because it doesn't break up, it doesn't burn efficiently. Right? Okay, great.